Chapter 3: Interdependence and Gains from Trade. Questions: why do people and nations choose to be economically interdependent? How can trade make everyone better off? What is absolute advantage? What is comparative advantage? How are these concepts similar? How are they different? So, interdependence. Every day, you rely on many people from around the world, most of whom you have never met, to provide you with goods and services you enjoy. Trade can make everyone better off. One of the 10 principles from chapter 1. We now learn why people and nations choose to be interdependent and how they can gain from trade. Asking the experts, trade between China and the United States. Trade with China makes most Americans better off because, among other advantages, they can buy goods that are made or assembled more cheaply in China. Well, 100% of economists agree trade is a good thing. Nobody disagrees. So let's look at an example. We're assuming two countries, that is United States and Japan. We are producing two goods, computers and wheat. There is only one resource, which is labor, measured in hours. How much of both goods each country produces and consumes? If the country chooses to be self-sufficient, and we're going to compare it with if it trades with another country. So let's revisit production possibilities in the United States. In the last chapter, we saw that US has 50,000 hours of labor available for production per month. Producing one computer requires 100 hours of labor. Producing 1 ton of wheat requires 10 hours of labor. We can plot that information on a two-dimensional graph. And so if we use 50,000 hours of labor to produce computers, that one computer requires 100 hours, that is 50,000 divided by 100, you get 500 computers. On the other hand, if we use the 50,000 labor hours to produce tons of wheat, 1 ton of wheat takes 10 labor hours. So you take 50,000, divide it by 10, and you get 5,000. Those are the extremes. We use that information to plot production possibilities frontier. So here, what the production possibilities frontier show is either you can use the 50,000 labor hours to produce 5,000 tons of wheat, or you can use that same labor hours to produce 500 computers, or a combination. Somewhere along the line, you can produce some tons of wheat and some computers. Okay, suppose the US uses half of its labor to produce goods. Let us assume that United States is not trading with any other country. In this case, they're not trading with Japan, and so it will use its labor hours to produce some wheat and some computers for its domestic consumption. So suppose US uses half of its labor to produce each good. That means out of 50,000 labor hours, 25,000, which is half of 50,000, will be used to produce tons of wheat. On the other 25,000 will be used to produce computers. If we plot that on the graph, you will see that US will produce 2,500 tons of wheat. That is 25,000 hours divided by 10. On the other 25,000 divided by 100, US will produce 250 computers. So its domestic production and consumption will be 2,500 tons of wheat and 250 computers. Here's a learning active learning. Use the following information to draw Japan's PPF. Japan has 30,000 hours of labor. Remember, US has 50,000 hours of labor for production per month. Producing one computer requires 125 hours of labor. Producing 1 ton of wheat requires 25 hours of labor. Your graph should measure computers on the horizontal axis. So on the horizontal axis, computers. On the vertical axis, wheat. So let us plot its production possibilities from here. The first point looked like 240 computers can be produced with 30,000 labor hours. How did we get this? The 30,000 labor hours divided by 125. On the other hand, if we choose to use 30,000 labor hours to produce tons of wheat, we will produce 1,200 tons of wheat. With that information, we plot the production possibilities frontier. So Japan can either produce 1,200 tons of wheat or 240 computers or a combination thereof with that. So if Japan does the same thing as the United States, it is not trading with US, it is self-sufficient, so it uses 30,000 labor hours and uses half of it to produce wheat and half of 30 to produce computers. What will be the domestic production and consumption? So here we will see it will produce and consume 120 computers. That is half of 30 is 15,000. You divide that by 125. And the other half, 15,000, will be used to produce 600 tons of wheat. That it's domestic production and consumption. So consumption with and without trade. So without trade, US consumers get 250 computers and 2,500 tons of wheat. Japan gets, consumers get 120 computers and 600 tons of wheat. So comparison, consumption without trade versus consumption with trade. We need to see how much of each good is produced and traded by the two countries. So let us see a trading scenario here. If US decides to trade with Japan, here is an active learning exercise. Suppose US decides to produce 3,400 tons of wheat. How many computers would the US be able to produce with its remaining labor hours? Draw the point representing this combination of computers and wheat on US PPF. As of course you can see, 3,400 tons of wheat would be how many hours? That would be 34,000 hours. That is 3,400 times 10. Remember, it takes 10 hours to produce a ton of wheat in the United States. So US uses 34,000 hours to produce wheat. The remaining it will be used to produce a computer. What about Japan? Suppose Japan produces 240 computers. How many tons of wheat would Japan be able to produce with its remaining labor? Draw this point on Japan's production possibilities frontier. So let's see a graph. Here is the production possibilities for the United States, and US decides to shifts its resources to produce 3,400 tons of wheat. That is 34 on the vertical axis. And the remaining would be 160. The remaining 16,000 hours, that is 34, 50,000 take away 34, we have 16,000 hours remaining. That will be used to produce computers. So if you divide 16,000 by 100 hours, you get 160. And so United States shifting its resources, trying to specialize producing now a combination of 3,400 tons of wheat and 160 computers. So, what about Japan? Japan is producing 240 computers, which requires all of its 30 hours. Remember, in Japan, it takes 125 hours to produce a computer. So, if you take 30,000 labor hours divided by 125, you get 240. Japan has used all its labor hours to produce computers. That means nothing is left for wheat. So Japan will produce 0 tons of wheat. So now that they have done their production, let us see if they can trade. Imports are goods produced abroad and sold domestically. Exports are goods produced domestically and sold abroad. Uh, Active learning. Suppose US exports 700 tons of wheat to Japan and in exchange imports 110 computers from Japan. That means Japan imports 700 tons of wheat and exports to the United States 110 computers. Number A, how much of each good is consumed in the US? Plot this combination on the US PPF. Number B, how much of each good is consumed in Japan? Plot this combination on Japan's PPF. Now, let us look at United States. Beginning with the original production possibilities frontier, United States produced 1,300 tons of wheat and 160 computers, and imports from Japan 110 computers. That is import. And exports to Japan 700 tons of wheat. So, what is the United States consumption? From 160, add import from Japan 110 computers. So, US is consuming 270 computers. It started out with 3,400 tons of wheat, exports or sales to Japan 700 tons, and US is left with 2,700 tons of wheat. That plotted on this two-dimensional graph, the point is outside the production possibilities frontier. This combination of 270 computers and 2,700 tons of wheat, United States is now trading with Japan and consuming outside its production possibility. Something that we saw in the last chapter, not possible. This is unattainable. There has got to be something good about this trade. Let us do the same for Japan. This was the production possibilities frontier of Japan. And Japan produced 240 computers, did not produce any wheat. And of that, Japan imported 700 tons of wheat from the United States and exported to the United States 110 computers. So, what is domestic consumption in Japan? 240 minus 110, which was sent to the United States, leaves Japan with 130 computers. Zero produced tons of wheat plus 700 imported from the United States leaves Japan consuming 700 tons of wheat. When we plot that information on this graph, again, that combination of 130 computers and 700 tons of wheat is outside Japan's production possibilities frontier. Outside its production possibilities frontier was not attainable last chapter. Something has to be good about this thing called trade. That means we make a conclusion that trade makes both countries better off. United States consumption without trade was 250 computers, and consumption with trade is 270 computers. Gain from trade, 20 computers. And wheat, United States was consuming 2,500 tons of wheat without trade Now, United States is consuming 2,700 tons of wheat with trade. United States is better off by 200 tons of wheat. What about Japan? Consumption without trade was 120 computers. Consumption with trade, 130 computers. Gains from trade, 10. What about wheat? Japan was consuming 600 tons of wheat without trade, and with trade, 700 tons of wheat. There is 100 tons of wheat as a gain from trade. Trade makes both countries better off. Trade is good. Okay? Where do these gains come from? Let us learn a new concept: absolute advantage. The ability to produce a good using fewer inputs than another producer. The US has absolute advantage in wheat. Producing a ton of wheat uses 10 labor hours in the United States, and it uses 25 labor hours in Japan. That is what it means. US has absolute advantage. Okay, ability to produce a good using fewer inputs than another. US also has absolute advantage in the production of computers. Producing one computer requires 125 labor hours in Japan, but only 100 hours in the United States. Again, United States has absolute advantage in the production of computers. So, if trade was based on absolute advantage, United States would not trade with Japan because US has absolute advantage in the production of both computers and wheat. But trade is not based on absolute advantage as we will see here. Okay? The US has an absolute advantage in both goods. So why does Japan specialize in computers? Why do both countries gain from trade? Now, let us see. Two countries can gain from trade when each specialize in the good it produces at the lowest cost. What do we call that? We call that comparative advantage. Okay. Absolute advantage measures the cost of a good in terms of the inputs required to produce it. Another measure of cost is the opportunity cost. The opportunity cost of a computer is equal to the amount of wheat that could be produced using the labor needed to produce one computer. We call that comparative advantage. Comparative advantage is the ability to produce a good at a lower opportunity cost than another producer. The principle of comparative advantage. Each good should be produced by the individual that has the smaller opportunity cost of producing that good. Specialize according to comparative advantage. Trade among nations is based on comparative advantage, not absolute advantage. The opportunity cost of a computer is 10 tons of wheat in the United States. How did we measure opportunity cost? The slope of the production possibilities frontier. So producing one computer requires 100 labor hours, which instead could produce 10 tons of wheat. 5 tons of wheat in Japan, producing one computer requires 125 labor hours, which instead could produce 5 tons of wheat. Japan has comparative advantage in computers. Japan should specialize in computers, and the United States should specialize in tons of wheat. Gains from trade arise from comparative advantage, that is, differences in opportunity cost. When each country specializes in the goods in which it has comparative advantage, total production in all countries is higher, the world's economic pie is bigger, all countries can gain from trade. Trade is a good thing. Active learning, absolute and comparative advantage. Argentina, 10,000 hours of labor per month. Producing 1 pound of coffee requires 2 hours. Producing one bottle of wine requires 4 hours. In Brazil, with the same 10,000 hours of labor per month, producing 1 pound of coffee requires 1 hour. Producing one bottle of wine requires 5 hours. One, which country has an absolute advantage in producing coffee? Number two, which country has a comparative advantage in production of wine? Answer. Number one, Brazil has absolute advantage in coffee, producing 1 pound of coffee, 1 labor hour in Brazil, but two in Argentina. In Argentina, comparative advantage in wine. Argentina's opportunity cost of wine is 2 pounds of coffee. The 4 labor hours required to produce a bottle of wine could instead produce 2 pounds of coffee. Brazil's opportunity cost of wine is 5 pounds of coffee. Trade between China and the United States. Let's see what the experts or economists say. Some Americans who work in the production of competing goods such as clothing and furniture are made worse off by trade with China. That statement, 96% of economists agree. 4% are uncertain, which means trade can be harmful to some domestic producers. Let us look at the summary. Interdependence and trade are desirable. Allow everyone to enjoy greater quantity and variety of goods and services. Comparative advantage, being able to produce a good at a lower opportunity cost. Absolute advantage, being able to produce a good with fewer inputs. The gain from trade are based on comparative advantage, not absolute advantage. Trade makes everyone better off. It allows people to specialize in those activities in which they have a comparative advantage. The principle of comparative advantage applies to countries as well as to people. Economists use the principle of comparative advantage to advocate free trade among countries. And that is the end of chapter 3. Let's look forward to chapter 4.